So welcome back to work with systems of equations. We're going to continue with what I would call strategy 2, solving system of equations using what we call the substitution method. So we have it highlighted over here. Our first move is to solve one of the equations for either x or y. The reason I say either x or y is I'm looking for the simplest math possible in doing this. So if I look at the first equation, I really don't like those numbers at all. The second equation, not much better, but I like these better than those. Now since these numbers are the same, it really doesn't matter who you solve for. I'm going to just go ahead and solve for y this time. So I'm going to have 6x plus 6y is equal to 0. And since I want to solve for y, that means I want to isolate it. So I'm going to get this, I'm going to move the 6x out of the way, so I need its 0 pair. I'm going to put a negative 6x over here and a negative 6x on the other side. We now kind of see that the 6x and negative 6x are going to zero out. So we have 6y is equal to, and that's just going to be a negative 6x. When you combine that, 0 doesn't add anything to it, so negative 6x and a 0 just is negative 6x. And then I have to get rid of the 6, so I divide each side by 6. The 6's divide out. And over here, the 6's divide out, and I get y equals negative x. So now I've done my first step. I solved one of the equations for x or y. But notice how I solved this one. My next move is to substitute the expression into the other equation. So notice how y is equal to negative x. I'm now going to focus on the first equation, which is negative 7x plus 2y is equal to 18. And since I said y is equal to negative x, I'm going to replace this y with a negative x. So what I have then is negative 7x plus 2, and I'm going to replace the y with what I'm saying y is equal to. It's equal to that expression, if you will. So I'm going to replace and put a negative x there. And that's going to equal then my 18. So now I'm ready to go ahead and just simplify this down a little bit. So I have a negative 7x, and that's really the same thing as a negative 2x equals 18. Remember, a positive times a negative just makes a negative. These are like terms, so it's going to make a negative 9x is equal to an 18. So we substituted in, we simplified. We still want to solve for the variables. So to get x by itself, I need to divide by negative 9. The negative 9s will divide out, and we end up with x equals negative 2. Now, once I solve for the variable, I want to use my other equation. I want to now substitute back in over here for x. So now I have this y equals negative x. And what I want to do is I want to put that negative 2 in for x. So what I have then is the opposite. And then that negative 2 is going to go in for x. And so what I end up with is the opposite of a negative 2. And we know that 2 negatives in that case would make a positive. So y would equal then a positive 2. So there's our solution. We found our x value and our y value. All we have to do now is put it in the form of an ordered pair. So negative 2, 2 would be my solution. Now if I graphed it using strategy 1, I should have two lines that intersect at that spot right there, at that point, negative 2, 2. But I'm not going to do strategy 2 this time, but feel free, if you wanted to graph those and verify that indeed that isn't the solution. Okay? What I can do at this point, I can prove to you that this indeed makes both equations true. So I can substitute that negative 2 in for x. So I have a negative 7 times a negative 2, plus then 2, and then y is equal to 2. That's going to be 2 times 2. Does that equal 18? Let's see here. A negative 7 times a negative 2 is a 14. 2 times 2 is 4. Does 14 plus 4 equal 18? So this ordered pair does make this statement true. The catch is it has to make this equation true as well. So let's see. 6 times, then again x is equal to -2, plus then 6 times 2, since y was equal to 2. Remember, this is your x value, this is your y value. So this value is going to go in for my x. This 2 is going to go in for my y. And it's supposed to equal 0. Well, we know that 6 times -2 is -12. 6 times a +2 is a 12. And we do know that a -12 plus a 12 does give me 0. So it does check out. That's a true statement. Okay? So I could verify that is the solution because it's supposed to satisfy both of my equations, and it does. Okay? So that's what we're looking for when we talk about systems of equations. Stay tuned for our, I think we're going to do one more with this.